Okay, I hope my voice is okay. I'm actually a little sick right now. I wonder why. I've been like stressing out for the past day or so. And I had my technical assessment yesterday. I had a hacker rank technical assessment, 5 questions, an hour, 15 minutes to finish it all. And I got through two and a half of those. So needless to say, I'm not feeling that great. Like physically and mentally, I'm out of it. I think I actually learned a good amount from that experience. The fact that these challenges you need to like get them done by about 15 minutes or so, in a reasonable way that works, and just like you can't really falter on that. So I'm going to be practicing today. I have an interview tomorrow, another one tomorrow, with another company, and they have 3 questions for 45 minutes. That's like 15 minutes each. Yeah. So I need to practice my butt off today. I have a bunch of challenges here that I wrote up, and I'll explain them before I go into them. But the very first one is actually the first one I got yesterday. Is called the Fibonacci, which I'm sure you are familiar with, but this one's like a slight variation. I'm also looking at this video I saw yesterday from HackerRank. They have a really good interview prep kit thing, and they had these tips and guidelines. So I watched this video here. So if you go to HackerRank interview prep kit tips and guidelines, they have this video called 7 Steps to Solving an Algorithm. Solving algorithm problems, and the person. So this is the person who wrote cracking the coding interview. So she knows what's up, and it's like really cool that they have these sets of instructions here. So I'm doing my best today to practice these 7 steps on the side. So you're meant to do the Fibonacci sequence. You're going to be given a number n, and you're supposed to return an array of length n of the Fibonacci numbers, starting with 0 and then 1. So that's a small change on Fibonacci, but really that's kind of it. Okay, so that's my listen stuff. So an example would be, well, I already have it here. Fib of 5, we can go 0, 1, 1, 2, 3, and then we can go like fib of 8 would be the same thing. So you can notice that like it's not returning the nth number, it's returning a whole array with it. So you have to basically keep adding to this array. So what I was originally trying to do with this when I was first tackling it was like, oh, I'll do a recursive call, easy, right? You don't need recursion for this. You don't need recursion for everything, even if it is a Fibonacci sequence. This is 5. This is 8, and I think that's 13 at the end. So that's what 8 would look like. So okay, so we have this. Let's talk about like a brute force or a potential solution. So I think a solution might be that you keep an array. Since you're being asked to return an array, I think this is fine to just start with that. Return array. And I would just like loop through n times and append previous to. So this inherently gives me a red flag that I need to have base cases here. So consider base cases of length when n is less than or equal to 2, because that will kind of like mess up this loop. So if I have some base cases, then I can I'll be okay as is. And I think that should do it. What would I do to optimize this? So do I have to go through n? So this is O of n, right? Literally n. I don't think you can. I don't think you can get less than that, because you need to like figure out what the previous 2 are. I think one minor optimization might be to actually store those previous 2 values, and therefore you don't have to like access them from an array, because that takes some time to like search through the array. So I think I might, if I'm here, I could like store previous 2 values for later. And so you just have in memory the number instead of trying to access it through the array. So that would work. That works fine. In fact, doesn't that alleviate the need for this base case thing? I think I could cross this out, actually, now that I think about it. Because if you have if you store the two previous, then you can store 0 and 1, and then just loop through that, and then you don't need to worry about base case. Huh, okay. Wow. I'm discovering things I didn't think about yesterday. Again, I was like under pressure, it's like hard to think, so. Okay, so I think this is a good place to start just coding at this point, so I'm just going to start coding. And I think I'll keep my comments here, so I'll just code around that. So I'll do function fib n, and then like that. Okay, let's move all this stuff in. Keep an array. Okay, const output as an array. Store previous to. Okay, so let first equals 0. Let second equal 1. So I don't need to consider this base case thing. And then I'm looping, so while n is greater than 0, I'm just going to use n to, and I'm going to decrement on n, because that should be fine, since I don't use, like, it's not, like, it's just a number. And then I just push, so output.push, first, so on the very first one, okay, so on the very first one, we don't have a first and second to add. So when n equals 1, we can just return literally that. And that's so there is a base case here. So I discovered that base case, which is fine. Any other situation though, you already have n being 2. That means you push. Oh, in that case, then you need to have this here. So you need to have a starting position. Okay, that makes sense. And I'm just going to return output. Okay, cool. So this is the first situation. Keep an array. This is the base case. And then now you're actually pushing first plus second. Which I need to store in a const new num equals this. So I'm going to push new num, and then I'm going to reorder the first. So first now equals second, and second now equals a new number. I think I can return my array at that point. Output. Okay. I would have actually written these tests first, actually. So let me just reuse those. Did I just copy empty space? Yes, fantastic. All right. Let's see. So I'm just going to console log on this. Right. All right. Oh yeah, that's fine. Okay. Fantastic. Okay. Let's save that. Let's go into notice that fib. Okay, let's see what we got here. So we got 5. The order, yeah, it's a little wonky there. There we go. All right, we have 0, 1, 2. That seems weird. So it's not working the way I thought. Also, this is 6. So I think the n being greater than 0 should be greater than 1. All right, so that's fine. All right. Yeah, the base case of 0, 1 needs to be just in there from the beginning. So this storage doesn't change that. You still need to have a starting position for those two. Okay, so that makes sense. Let's just do it like this. So and I think this will work. Okay. So if the n is equal to 1, it just returns to 0. If it is n is equal to 2, it will run through this. N is not greater than 2 in that case, so it just returns output, which is 0, 1. And then anything else will just add on to 0, 1. So let's see what that looks like here. And this is what I was looking. Okay, let's look on the time. Let's see if it's 15 minutes or not. 3 minutes and 40 seconds to spare. Holy crap, man. And that's like an easy one. Well, so when I first did it, I was again trying to do the recursion thing, and that really is not a good place to start. So planning it, I think spending time early on and just like getting an understanding of what it's asking, getting an understanding of the logic of how you would even go about solving the problem, even if you don't know how the best way of solving it, even like a brute force would have been better. So I really was struggling with a lot, I was struggling with not necessarily solving it, but just A, working under pressure, and then B, having a good methodology for just like tackling something regardless of how complex it is. That is my Fibonacci sequence. I hope you liked it. And I'm going to be doing the next one. I'll figure out the next one. So I hope that was enjoyable and useful, and I will see you in the next one.